Okay, this is Geometry 4.6. Our objective today is to prove right triangles congruent using hypotenuse leg theorem. As I was telling the students here on campus, enabled to use this hypotenuse leg, we have to have the triangles be right triangles. If they're not right triangles, we got to say the right triangles in our proof. So we're doing a proof here. Number one, given triangle PRS and triangle RPQ are right angles. Hey, that's cool. I don't have to do the perpendicular two-step. They told me the right angles already. Okay, I can talk about segment PSP congruent to segment QR. So now, with the information that's provided, I have this side, maybe I have that side. Let's go back to here and then see if that's maybe. There we go. I have that side and that side. And then I have, thank you, Mr. Rashab. I have PR and RP because they are actual reflexive property. But let me finish out the given, and I got my reflexive property as I'm getting that going. And my last thing I've got to say anything about here, if I can get this screen a little bit different. There we go. Not that decides the thing today. I'm just really sad I don't have coffee right now. This is a good coffee time. Thank you. And go ahead and fix yourself the rest of the way. Thank you. We got to do that, so I get that out of the way. Sure, that'll work. Okay, so now we're looking at this, and we have our reflective property. I'm not saying that the two right angles are congruent to each other. It's not going to help me because we don't have an SSA congruent statement. I am, however, going to use the fact that those are right angles, and right angles inside triangles make right triangles. So by definition of right triangles, I know triangle PRS and triangle RPQ are right triangles. Okay. Now I've stated that these two triangles are right triangles. According to the theorem HL, I can now say that that longer side opposite the right angle is the hypotenuse, and that one of the sides that make the right angle is a leg. And because of that hypotenuse leg, I'm allowed to say that the two triangles are congruent as hypotenuse legs. Is there a reason for them being congruent? We good? Got it written down? We got a couple left. Now keep in mind, it's our fifth triangle congruence statement, okay? And notice how we have to, the information we have to have to use it. We have to know that the triangles are right triangles. And if we don't know, if we have to know we have right angles, and then we have right triangles by definition of right triangles, okay, as we're working with it. Now, with that said, there are other things we can learn about, and let me clear this stuff up. I'm not sure why it's still there, but I'm not surprised with how everything's been not going away today. It all comes back. Do you guys remember seeing a bracket around formulas before, or at least relationships? Last year, when you guys started second semester in Expo, you had something called systems of equations. Do you remember that? It's where you had two equations, two unknowns, and you had to find where they crossed because they were linear relationships, and they're find where the lines cross. And well, this is going to be an example of using those skills. And I'm going to review them as we go through, but I just want to make sure you know that we've done this before, but just because we've done it before doesn't mean we're awesome at it. Okay, so let's talk about it. If you have some questions, ask, okay, as we get going. But let's use this hypotenuse leg stuff. First of all, I got a hypotenuse, x plus 3, and another one, 3y. Okay, that's one relationship. My other relationship is x is equal to y plus 1. Those are my leg relationships. Okay, and when you first saw these, you saw it this way. Put a bracket around it, and they said, well, x equals y plus 1, and x plus 3 equals 3y. Find x and y. Well, we're going to use substitution for this solve. Okay, you learned how to do them graphically, by substitution, and by something called linear combinations. Find substitution's the easiest one to cover and do it relatively painlessly as we go through, because we've been doing substitution for the whole year so far. So what I'm going to do, where I see x, I'm going to plug in y plus 1 right there in the other relationship. Okay. So when I do that, I write everything else. I got 3 equal 3y, and I'm going to plug in x plus 1 or y plus 1. Okay, as I go through there, because x is the same as y plus 1. That's what that relationship stated. Now, after I do that plug-in, I solve everything exactly the way I've been doing it since what, 5th, 6th grade, whenever you started solving. Okay, so go ahead and get her done. We got y plus 4 equals 3y, and now I got subtract y from both sides, 4 equals 2y, and my final step, divide by 2, and y is 2. You okay with what I did? The big step is this one right here in making that substitution. Are you okay with why I did what I did when I did it? I got some funny faces out there. Questions? Good, we're all right. Now keep in mind, it is a system of equation and it has two unknowns and two relationships to help you find those unknowns. I have one of them. So what I need to do is recognize that I can take my answer for y and I can plug it back into the original equation, one of the original equations. I don't care which one. The reason why I'm doing this one is because y is on just one side, and I'm going to plop it in right there. So now I have x equals 2 plus 1, because y was 2, and I find out that x is 3. So this is my final answer, that y is 2 and x is 3. Now I've got some folks that are very happy that they found an answer they get to go on, but I like finding the right answer. Every time we do these, you should be able to check your work. So whenever you see y up in the original equation, you can check. So this is 6. Okay, and x is 3, 3 plus 3, hey, this is 6. So that worked, that was pretty cool. And when x is 3 here, because x is 3, and I put 2 plus 1, hey, that's 3. So we said that this side was equal to this, we said that this side was equal to this, and they are. So it worked. What I'd like you to try is realize we're gonna do exactly the same thing. Okay, and people are like, what? So I'm gonna bring you through it. Okay, we're going to have two relationships. Let's set up the two relationships. The two relationships are sitting with the first one with my hypotenuse. The hypotenuse are across from the right angle. So I know that 3y plus x is equal to y plus 5. Now, the legs are my other ones. That's these guys right here. So I got y minus x is equal to x plus 5. Now, I'm going to do something as I go here to help me substitute easier. I'm just going to kind of solve for a couple things. In the green, I'm going to get y by itself. In the blue, I'm going to get the y, the other y's on the same side. So I'm going to subtract y, and I get 2y plus x equal 5. Okay? You all right with what I just did? Now, the reason I did that is so when I substitute, I just substitute in one spot. I don't have to substitute in multiple spots because I got the y's all together, kind of. So now I'm going to go, well, you know, 2 times whatever y is. I'm going to write that in green because that's what it is over there. I just popped that in for y, and that's what it was. You okay with that? And now I evaluate. And I evaluate exactly the way I learned how to distribute stuff and solve for things, you know, as I've been going through my math experience. So I got 4x plus 10 plus x equal 5. I got 5x plus 10 equal 5. And I'm looking at this as 5x equal negative 5. And hey, x is negative 1. That's cool. I kind of went off my page, but I wanted to make sure that you saw x is negative 1. Maybe I can adjust this a little bit. Fit everything in there. Yeah, it's better. But now I know x is -1. So let's take my -1 up here to find out my y is. Because now I know that y is equal to 2 times, I put in my -1 for x. So -2 plus 5, so y is 3. So x is -1, y is 3, that's my answer, and I can check. Y is 3. So if y is 3, I got my blues are 8, y is 3, that's 9 plus -1, that's 8. And y is 3 minus the -1 is 4 on the greens, and -1 plus 5 is 4 on the greens. Hey, they totally work out again. That's totally cool. Okay, so I've checked my work. I didn't even write it down. I just kind of plugged it in and talked about adding and subtracting my x and y values. Now, that's using systems of equations substitution method. Okay, that's what I would set up. Are the two triangles congruent? And people are shocked that I'm just going to go back to something like this. I have a 10 on the hypotenuse. I have a 10 on the hypotenuse. I have a 6 for a leg. I have a 6 for another leg. Hey, you know something? I got hypotenuse leg. I got two right triangles and congruent hypotenuse, congruent legs. I'm good. And I can set this up as a triangle congruent statement. They say, hey, are they? And if they are, I can write a triangle congruent statement. And remember, order matters when I write my triangle congruent statement. I'm really doing this because I need to have you see triangle congruent statement again in front of you as we go through stuff. Okay, so now I'm looking at BCA. I went from the right angle to the leg to the hypotenuse. Right angle, the leg that's congruent to the hypotenuse, EFD. Okay, so that's how I lined them up. It's your turn. It's your turn. Do 4, do 4, do 4. Do you see that this is a right angle too? Because of vertical angle theorem, okay? So I got two right angles, two sides, one of them's a hypotenuse, one's a leg. Hey, they're totally gonna work, and I've got my triangle congruent statements all set up, okay? As I'm walking around, let me know what you think about some stuff, if you got some questions, but more importantly, do 5, do 6, see what you got for answers. Get them done. Do I have a right angle here? Do I have any information to help me with the right angle in number 5? So I gotta say no. They're not gonna be congruent. Not with the information I have. In 6, what do you think? I have head bobbles. I like head bobbles. It's okay. I want to hear your voices. So what do you think, Heftbacker? They were? Yeah, they are. Nice job. And did you get your triangle congruent statement? Nice job. Thanks for going out on a limb. Okay, that's all we're doing. Okay, so now let's start reviewing what we kind of went over. Okay, turn the page. And again, I don't know what I'm doing with this, why these are still here. Turn the page, do 7, do 7, do 8. Absolutely nothing is working today for me. Hoping that this video works. Are you okay with those? Are we doing all right? go after 9, get after it, get questions, ask. I can promise you this one thing, a question that requires these skills is already on the test. So if you got a question, ask it, because you'll be asking it on the test and I'll say I can't help. You guys are doing that, take attendance. Okay, so when I'm looking at this next one, it's a little bit more involved, but what's really nice about 9, I don't have to use systems on it. I do have to substitute to find my other value, but if I'm careful and if I pay attention, I'll be okay with finding things. So the first thing I have is 13 equals 4x plus 1. Well, that's pretty cool. 12 equals 4x and x is 3. Okay, my second relationship, I have 2x plus y equal 8x minus 2y. Okay, well, if I get my 2y together, I've got 2x over there, so I got y equals 6x minus 2y. I got 3y equals 6x. And then I go, oh, you know, check it out. X is 3. So I just pop that in and go, oh, well, 3y equals 18, and y is 6. So I got that golden nut. Okay, did you get y is 6 and x is 3? Okay, I got some head bobbles, fantastic. They don't ask me to do anything else, but I can check it. So I'm going to check it out. 3 goes in for, 4 times 3 plus 1. Hey, that's 13. It's totally what I said it would be over here. And if I go over here and check out x, which is 3, that's 2 times it is 6, plus 6 more is 12. So this is 12 here. And if I go 3 times 8, which is 24, and 2 times 6, which is 12, hey, that's 12 over here. So I've checked my work and I've done the right things. That's awesome. I know I'm right. So now I get to go on to 10. And I'm checking this. I got 2x plus 1 equals x plus 3. I look at this. I've got x plus 1 equals 3 because I subtracted x, and I subtract 1, and x is 2. Okay, so I'm going to check it. 4 plus 1, hey, that's 5. And then this 2, hey, that's 5 as well. Awesome. But now this next relationship, I'm looking at the idea that x plus y is equal to 3x minus 3y. Okay, well, I'm going to subtract x, I'm going to add 3y, so I'm going to subtract x first. I got 2x minus 3y. I'm going to add that 3y, I got 4y equals 2x. And I already know that x is 2. 4y is equal to 4, and y is equal to 1. And so I can go over here and check that. Checking y is 1, x is 2, this is 3, y is 1, x is 2, that's 3. Hey, cool. Totally worked out again. Totally golden. Love it. And I got some people going, oh, I love this algebra stuff. It's awesome. I love algebra land. Bloom took us to algebra land. And then he goes, oh, by the way, this is a review on the stuff we've done. So we got to do another proof. Okay, so let's look at that. Now, again, start with my given, and this given's kind of long, so I'm going to put it on 2 lines. Okay, so I've got it all written down. And now, I got a hint over here. They tell me that segment AD bisects segment EB. AD's the knife, and it's cutting EB. So I know EC and BC are the 2 pieces that's left over, okay, that are equal. So I've got I'm looking at this, I'm going, boy, you know, I got a hypotenuse leg coming on here. So if I got that happening, and they already told me that angle ECD and angle ACB are right angles, oh, thank goodness. I can just say that, hey, you know, I'm working with two right triangles. And because I'm working with right triangles, and the fact that EC and BC are congruent because a definition of segment bisector, I've got two triangles congruent because of HL congruence as I'm going through here. Okay, so as I'm checking this out, my next step, oh, I've got this in there. My next step is that the triangles are right angles, by definition right triangles. And then I've got EC congruent to BC because of reflexive. And then my very last statement is exactly what's here. Down here, triangle ACB is congruent to triangle DCE. Yep, because of HL congruence. And I'm good to go. Now, keep in mind, the next 5 questions takes about 2.5 minutes. I have people that are just finishing up writing down this proof, and I want you to do those last 5 questions as a review of what we know about HL congruence. Okay, go ahead. Now, here's the deal. I got some people right now, they're like, okay, Bloom, this is, geez Louise, all this stuff I tap on is still here. This is what we've got. We've got this going on with angle A and angle Q must be right angles. Are you okay with that? Are you further okay that because I have reflexive property of AC and CA, the only other thing I need, okay, and by the way, the ACCA isn't items I need. It's already there. I just wanted to point that out. Angle D and angle B must be right angles. Are you okay with D in A? Are there any questions? Now, in 14, I need one more thing, and I need a specific side. I already know the right angles, and I have a leg. Legs make the right angle in the triangle. So I need the hypotenuse. Okay, ln and xz, ln coming down and xz is coming down. I need the hypotenuse both to be congruent to each other. Okay, and the last one, ts is congruent to itself because of reflexive, but tr congruent to tv has to happen for this to work. Again, I need to have the right triangle's longest side, which is the hypotenuse. Okay, now answer the last question. Now, because people can racing on, I've got to ask, did you really pay attention to the diagram? Or do you just kind of answer it real quick? Because it looked like the same numbers and it should be yes. Look at the diagram, because it's no. Who got caught? Okay, about a third to a half today got caught on rushing off because they totally got it. It's got to be right angles. It's got to be the same numbers. That totally works. But you have to pay attention. I've talked about this hasty search thing. Okay, like you're stressed, you're in a rush, you don't really pay attention to everything, and mom told you something was right by your bed like 12 times. And this exchange goes, Mom, I can't find it. She goes, it's right there next to your bed. Mom, I can't find it. No, it really is right there next to your bed. No, this goes on for long enough, and you're just like frustrated. Mom's frustrated. Mom comes up the steps, and you can hear them, the steps. Okay, you can hear her stepping, and then she walks into your room. She doesn't say a word. Bends down, picks it up exactly where she'd been telling you for the last 5-10 minutes, however long this exchange took place, and she hands it to you and does the eye roll the way mom only can eye roll at you, and turns around, doesn't say a word, and walks out. And you're going, oh yeah, I saw that, not at all. And it was there the whole time. You win. This problem is an example of that, because the 25 length on one is the hypotenuse and on the other it's a leg. That's why they're not congruent. Okay? They can't be. It's two different types of triangles. And for this one reason is why we're about to do what we're going to do. On Wednesday, I had you guys do a formative quiz. And the quiz was huge. You had the scale scroll back and forth in the questions. Okay? And some people didn't adjust their screen. What I need you to do is physically be aware that adjusting your screen will help you improve your score. Okay? Because you didn't adjust your screen, you didn't see all the distractors at the same time, so you just picked the one you thought was best of the ones you saw, and consequently did not do well. Okay? As a matter of fact, changing the screen size today changed people's scores by as much as 60 percentage points. Okay, so what I want you to do is pull out your Chromebook, get on to that same quiz. We're taking the same quiz, and I got some people, boom, what if I did really well? I want you to do really better. Okay, and if you did really awesome the first time, I want you to do that really awesome the second time. But my purpose of this is about you learning how to do screen change. We're familiar with what the AMP test looks like. So open up your stuff. You're going to the triangle formative quiz. Okay, and I want to, do you guys know how to adjust your screens with the plus or minus with control? Plus, control, minus. As an old guy without glasses, I'd use this a lot, but the minus minimizes the screen, makes it small. I shouldn't say minimize, it makes the screen smaller, so the whole thing will fit on there. And it's pretty nice to be able to use. But what I want you to do is retake the quiz, but do not answer questions unless the entire question is on the screen at one time. You can see the actual question, the diagram, the words, and your choices. Minimize your screen down so you can see it all. Okay, on each question. You shouldn't be scrolling across to see your distractors that are there, because you'll just pick one and move on and you won't see them all. It has changed people's scores today. Okay, so go ahead and get it done.